Hey guys, today we'll have a look at what's inside this package, and more precisely this M18 FPD2 drill driver. As you can see, when we insert the battery and pull the trigger, we can hear a distinctive clicking sound. So let's try and find out what's causing this. To open it up, we need to remove the back cover and the front screws holding the gearbox in. This allows us to pry the two halves apart. With that done, we can test the most common parts, such as the motor windings, and we know that the switch works, as we could hear the clicking noise each time we pressed it. As the windings test fine, and there is no visible signs of damage, we'll need to diagnose the electronics. So let's disconnect everything we can to prevent any damage from the heat which we'll use to remove the adhesive covering the main boards. I typically start off by cutting the glue on the edges to remove the plastic mold first. All the cuts need to be done with a high degree of caution, as we risk cutting the traces and damaging the components on the board. And with the radiator removed, we can now take a look at what is a bridge structure of 12 MOSFETs controlling the motor. The MOSFETs are arranged in pairs, with 4 FETs for each of the motor phases, 2 on the high side and 2 on the low side. And using a simple measurement between ground and any of the motor phases, we can see we have a short to ground. This indicates at least one of the MOSFETs on the low side has failed. We can now identify which MOSFETs are the low side, as their drain will be directly connected to ground, and we know that the drain is the casing from the datasheet. Using this knowledge, we can now disconnect each phase to find out which pair is causing the short. This is necessary because in DC measurements, any motor winding will appear as a short connecting all phase wires together, making it almost impossible to point out which phase is causing it. And with the black wire now disconnected, we can check again. And we can see that the short is gone on the black phase, but is still present on the red and white wires. So after disconnecting one more wire, we can see that the short is on the red wire phase. We have to make an educated guess as to which one of the low side red phase MOSFETs is faulty. Now if we look under a microscope and zoom in closely, we'll see a visible heat discoloration on one of them around the 8, M, and 2. And after testing it, it was in fact this MOSFET that was shorted. Since the IRF 7480 are difficult to obtain currently, I replaced it with a similar one used in some of the Bosch tools. You can see that after soldering it and quickly reassembling, it does work now. Thanks for watching. If you liked the video, consider subscribing. And if there is anything else you'd like to see fixed, let me know down in the comments.